In this lesson, we shall focus on mathematics, MATH141 Calculus UKZN. We shall look at improper integrals and a lot of techniques of integration. Right, first things first, we look at part 4 of the module 1b. Right, let f be a function whose second derivative is continuous on the closed interval from -1 to 1. Use integration by parts to show that this is the case. Right, so now we need to remember the technique we call integration. Integration by parts. So that now integration by parts is clear. The integral of u, the v is uv minus the integral of v du. Right, so we are keeping on this, and then we shall look at the other sections as well. So now we need to choose here, given the integral x, f double primed this dx. What you do, you need to so now you need to look at these. And once again, I remember we had a discussion about this. So you need to look at this and look at what you need to do. Because the x must be u. Why? The x must be u. And then everything else can be dv. Which means dv now is f double primed this dx. So that you would have du. Du is what? Is dx. And then when you do the integral of dv, you'd have... yes, please.
So the x must be always u.
Yes, the x must be always u. Why? Because we want to... u is made, or that part that is made u is the one whose derivative will sort of reduce to a constant, at least. All right, so now, for example, if a student is going to think that f double primed is going to be made u, it's not going to help, because if u is f double primed, then the problem is that then it's already second derivative. Then now you need to, u must be differentiated. So if u is f double primed, then the derivative is going to be f triple primed. So it's not going to work. So if we make u to be x, then the derivative of x is 1. So it's going to work because the derivative simplifies to a constant. Or even if x was x squared, if x was x squared, still we would make u to be x. Why? Because the derivative of x squared will become 2x, and therefore the power of the x will then decrease. Okay, that's something. So u is made that expression whose powers will decrease under differentiation. Right, so we have this. So now if you have v equals this, then the integral of this. Okay, the integral of the v is it's v, f primed. Then the integral of f double primed is f primed. Right. So we have this exactly. Right. Okay, we continue. Now with this, then we are in business, because it means that we can come here and do the integral. So the integral now, okay, if we do integration by parts, normally we leave out the limits of integration and first do the integration, and then we'll plug in the limits of integration later on. Okay, with that mentioned, then it means that we take this integral as it is. We want to just get the integral before we substitute the -1 and the 1. Now, take a look and think with me and reason with me, because at this point, this integral here must be, so this integral is u dv, it must be uv. What is u here? U is x, so we put x. V, what is v? V is f primed. Minus the integral of v. What is v? V is f primed. Then we have du. What is du here? Du in the formula. Du in the formula. Du is x. is rather du is dx. Like so. Take a look. Well, it means, therefore, the integral of f double primed of x dx. Okay, so the integral now is equal to what? This integral is actually, can leave out first the limits of integration one more time, leaving out the limits of integration one more time. But what we're able to determine is that this is xf primed of x minus, what did you get that to be? We got also that to be like, the integral of f primed of x dx. The integral of f primed of x dx. Okay, so that in the end, then, you have, now this is x f primed of x. Okay, the integral of f primed. What is the integral of f primed? The integral of f primed, so the integral removes the prime by the fundamental theorem of calculus. Fundamental theorem of calculus, therefore this becomes just f of x. Okay. In general, we need to add c. But obviously now we're going to include the limit. So if we include the limits of integration, then we remove the c. So the integral from -1 to 1 of x f double primed of x dx. F primed of x minus f primed, and then we integrate from -1 to 1. So now, you have this, which is 1 f of 1. Okay, in the place of x, now you put 1. Can do it at the bottom here, just to create a little bit more space. Right, so doing it at the bottom here, we have that. If you plug in the 1 in the place of the x, then you have f primed of 1 minus f of 1. Okay, we have put the 1. And then you put -1 in the place of x. So in the place of x, now you put -1, and then you have f primed of -1 minus f of -1, like this. Meaning is, okay, f primed of 1 minus f of 1 plus f primed of -1. Okay, negative times negative is plus. Negative times negative is also plus of that. Okay, we check this, so it must be the same as this. Right, so the answer is f primed of 1 minus f of 1, etc. Okay, must be the same. So, but this answer can be written, therefore, as the following. Okay, we can just rearrange these things because this guy is just organized it differently. It's okay, it doesn't really matter, but we can write it like this. F double primed of x dx. Okay, so, which is f primed of 1 plus f primed of -1. Okay, f primed of 1, f primed of -1. Minus f of 1 plus f of -1. Like this. Okay, take a look at this and reason with me because, yeah, that is the answer. Any question on this integration by parts problem? Just a small little problem. Okay, think about it. Make sure you understand it. But this discussion is recorded for control and quality purposes. You'll get the recording at the end of our discussion. We have about 2 hours, yeah, a little more than 2 hours. If we can run up to 10. But we run up to 10, provided you don't have things to do, and you need to let us know if you have stuff to do. Okay, because you might be having other things to do. Number 2, we need to evaluate the integral using an appropriate trigonometric substitution. Okay, so here we need to use a trigonometric substitution. So in other words, often we can't do it otherwise. Okay, so this one here is called an indefinite integral. An indefinite integral. An indefinite integral. Okay. So now with x squared, which you divide by the square root of 9 minus x squared, dx. Okay. What is this? Right now, to do this one, we need the 9 must be 1. The 9 must be what? It must be a 1. So since the 9 must be a 1, we need to think about it. So the way to do it, because the 9 must be a 1, the way to make 9 1, we must make the x to have a 3. So that when we square the 3, then we'll get a 9. So the way to do it, we let x be 3, the sine of theta. Let x be 3, the sine of theta. Okay, because now when you square the 3, then you get a 9. And then you can take out the common factor 9. But also you can take out the common factor 9 before, but yeah, it's the same. So there are too many ways to kill a cat. But my advice would be in the case like this, just to save time, you can just let x be the 3. Why the 3? Because you're going to have, there's a 9 here. Then you take the square root of the 9, the square root of the 9. Right, so this becomes like the square root of the 9, which is 3. And then you put sine theta. Why are we reasoning like this? Okay, it is by dint of the high school result on trigonometry. Right, so you know that the sine plus cosine squared equals 1. Meaning that you have the sine squared, 1 minus cosine squared theta. Okay, so because sine squared plus cosine squared theta is 1, then here this one is going to be like 1 minus. We need a 1. Okay. Okay, now let us see what to do. But moreover, we need to find the derivative of this. So which means that dx, the derivative of the sine, is the cosine. So it is 3 cosine theta, d theta. Okay. Upon careful examination, when you have this particular integral, you take the square root. So you substitute everything. For example, in the denominator, you would have 9 minus, and then the x is 3 sine theta. And then you square it. What is the x? The x is 3 cosine theta, d theta. The x is 3 sine theta squared. Okay, let us deal with this. So that now in the top, you'd have the 3, you square it, it becomes a 9. It becomes a 9 sine squared theta times 3 cosine theta. Okay, then you have 9 minus 9 sine squared theta d theta. So that now in the denominator, you're going to have what in the denominator? Right, so the top is going to be that. But in the denominator, then you have the integral of the square root. So you'd have the square root of 9, then you'd have the square root, take out the 9 out, is the square root of 9, and then you have 1 minus sine squared theta. And then you have 9 sine squared theta. Okay, and then now there is 9 by 3. Okay, which is 27. 9 by 3 is 27. Cosine theta. D theta. Okay. You have the integral of the following. The square root of 9 in the denominator becomes a 3. So that you have 27 sine squared theta. Cosine theta. Divided by the square root of 9 becomes a 3. The 1 minus sine squared is cosine squared. The square root of cosine squared is what? The square root of cosine squared is cosine theta. D theta. Cosine theta cancels cosine theta. 9 divides 27, giving us, or 3 divides 27, giving us a 9. Okay, let me just remove this one here. Maybe I can remove the crossings. Except the cancellation steps. Okay, so that at this point you divide 27 by 3, you get a 9. You get a 9 sine squared theta d theta. What is the integral of the sine squared? We remember the trigonometric substitutions. What are the trig substitutions? Right, the trig substitutions allow us to do the following. We know from metric that cosine 2 theta is 1 minus 2 sine squared theta. If this is given, then we have the sine squared of theta. Okay, so yeah. 1 minus cosine 2 theta, you divide by what? You divide by 2. You divide by 2. Okay, now you have a 9. The sine squared is 1 minus the cosine of 2 theta, you divide by 2. Okay, so you have this one, we continue. We have seen that we actually have a 9 over 2, right? See? So we're going to have a 9 over 2, then 1 minus cosine 2 theta. 9 over 2 integral of 1 minus cosine 2 theta. Yep. Okay. 9 over 2. What is the integral of this one? It's theta. 1/2 sine 2 theta. The integral of the cosine is the sine, but the half goes like this. So you'd get this answer. But again, you need to remember what we started. But we remember that x is 3, the sine of theta, because the given problem was in terms of x, we must write our answer in terms of x, so that we can be able to do the necessary replacements. We can be able to do the necessary replacements. And ordinarily, to do this one here, you need to perform some substitutions. What are the substitutions? Right, now we can make the x over 3 is sine theta. X over 3 is sine theta, which means that you have the arcsine of x over 3, which is theta. 9 over 2, 1 minus cosine 2 theta, d theta. It's 9/2. What is theta? Theta is actually exactly the arc sine. So you have 9/2 arc sine of x/3 minus. Okay. Then we come to this one. This one, you can write it differently. You can write it differently. Sine 2 theta from metric. Sine 2 theta is 2 sine theta cosine theta. Sine 2 theta is 2 sine theta cosine theta using the trig identities we know from school. And then now you multiply here. This is going to be 9/2 arc sine of x/3. Right, then the 2 cancels. 2 cancels, giving us exactly minus the 9/2. And then you have sine theta. Sine theta is x/3. All right, cosine theta. Cosine squared plus sine squared. Okay, let's take a look. So now we want to find cosine theta. We need to find cosine theta. You can get it using this one. Because if you already know that x is actually this one. So we know that x is 3 sine theta. So come here. You can even use a triangle for this. Normally we use a triangle for this. Because if you use a triangle, let me just use a triangle. Let me use a green triangle. Green triangle. Right, using a green triangle, we obtain the following. Okay, these triangles are always acute angles. So you can come here. Okay, we've already said here that sine theta is x/3. Yeah, so that if this is the angle theta, then the sine theta is opposite of hypotenuse. SOHCAHTOA. SOHCAHTOA. So the sine is opposite of hypotenuse. Opposite of hypotenuse. This one here is the square. 3 squared. It's 9. By Pythagoras theorem, this is going to be 9 minus x squared. Okay, which is the one we can use. Sometimes we use the triangles to perform integration. Right, or can use the identity above, but the triangles are more popular, and I feel that they're easier to use. So that now we're in a position to do the following. So, yeah, the sine of theta. Sine theta is x/3. Cosine theta. This is theta. Cosine theta. Cosine, according to SOHCAHTOA, is adjacent of hypotenuse. So that you come here. Adjacent of hypotenuse is going to be exactly 9 minus x squared. Hypotenuse is 3 plus c. Right. So that we have 9/2.
So,
One, yes, please.
can you please explain this part? I got lost the part where you said, you see where it's written 1/2 times 2 sine theta cos theta.
Okay, 1/2 times 2 sine theta cosine theta. Okay, so that part is from here. That part is exactly from here. This one is this. You know? Because,
Okay, I see. So what we're supposed to substitute there? Or you
yeah,
substituted after? Okay, I
okay,
see.
okay, yeah. We use the what? We use the fact that sine 2 theta. The sine 2 theta which appears here is equal to what? It's equal to 2 sine theta cosine theta. So sine 2 theta is 2 sine theta cosine theta. So in other words, sine 2 theta is 2 sine theta cosine theta. Yet, So we're using the double angle formula. But here, in the place of the theta, theta is arc sine x over 3. So that in the end, then this integral here is going to be exactly 9 over 2. Okay, this integral here, let me write it in red. Make sure it's maybe a bit brighter. So you have 9 over 2, then you have arc sine x over 3 minus. You come here, 3 times 3. 3 times 3 is 9. 9 cancels 9, giving us 1/2 x, the square root of 9 minus x squared plus what? Plus c. So this is the answer. You can see it's exactly the same as the one they gave in the TAT. It's exactly the same as the one they gave in the tutorial. So this was an example of it was the 2a, and the 2a is called an indefinite integral because it has no limits of integration. We just had to do the integral, and we have evaluated the integral. Okay. We evaluated the integral. We evaluated the integral. Okay, we move on. So we got exactly the answer that they gave in the tutorial. And then we move to the next TAT question. We move to the B part. So B is the same, but what is the difference? Okay, so you are ordered by the fact that it's a constant minus a variable squared. So yeah, the substitution is going to be the same here. You're going to use still the sign. You can use the cosine if you want. The answer is going to be the same. But the problem with the cosine is that the derivative of the cosine is negative sign. The derivative of the cosine is negative, so we don't like it because it's going to create some sign changes. It's okay, it's correct. But yeah, the mathematicians, I think, very popularly the sign is used. So you have these now. We divide by x squared. And then we have x squared. Dx. Okay, now the same applies to this because it is a number minus x squared. Like this was a number minus x squared. We're going to let x be 4 sine theta. Dx. Derivative of the sine is the cosine, so that is 4 cosine theta. D theta. Right, so we're good.
May I ask,
Please come again, yeah?
yes, how do you know which trig substitution you should use?
Yes, because if it is a squared minus x squared, then we let x be a sine theta. You know? For example, like this one is plus. So if it's plus,
Yes.
you use tan theta. So x would have to be tan theta. But yeah, a tan theta. So it depends on the x squared. Yeah, if it's a squared minus x squared, then it becomes a sine theta.
So it doesn't depend on the structure.
Yeah, it doesn't depend quite on the structure. Doesn't depend.
Okay.
Because you see, yeah, because now this one has an x squared there, but it must work the substitution. It must work.
Because
Yeah.
I thought you were supposed to use a sec for this one.
Okay.
Since
Yes. Okay. I get your point. Okay, that's interesting, the sec. Okay, let us reason together and see if the sec can work, because it doesn't mean that you can only use one substitution most of the times. But I want us to reason together and see if the sec can work. So I'm going to do some rough work. as follows. Okay, these things, all of them come from the identities we know. They all come from sine squared theta plus cosine squared theta equals 1. Okay, so now let's go step by step. If we want to get the sec here out of this identity to see if it's going to work, okay, we divide this by what? By cosine squared. So in other words, I'm going to write here. So you have sine squared theta, and then you have cosine squared theta, it equals 1. You divide by sine squared theta. You divide by sine squared theta. By cosine squared theta, so I want to say, because we want to get the sec. Want to see if the sec is going to work. The sec works in some integrals. But let us check now here. If we divide by cosine squared, you divide by cosine squared, you also divide by cosine squared. So sine squared over cosine squared is 10 squared. Plus 1. It is sec squared. Okay, look. Now, then sec squared is going to work if only it is, then you move the 1. So the identity we use for the sec squared that makes the things to work is if we have sec squared minus 1. So as much as obviously I'm thinking, obviously I was thinking like you. I mean, I think if it's minus like this, we think sine, we think sec. So we need to decide which one. But can sec work? Sec is going to work if it is x squared minus a number. Because it must be sec squared minus a number. Then, if it's not x squared minus a number, then sec is not going to work. Because it's not going to dissolve this. The sec must come first. So the variable must come first. It must be the sec squared, then minus a number. Then the sec is going to work. Okay, I'm sure we'll get problems like that. So in the same way, I mean, our minds normally switch naturally between the sine and the sec. But yeah, you can use this one can only be done with the sine or cosine. The others can't work. Or you can use hyperbolic functions, but yeah, those would be too extreme. You can use hyperbolic functions. What hyperbolic functions can you use? So you can think about the hyperbolic functions as well. You're gonna think, okay, I want to speak about it just in a minute, hyperbolic functions. I'm not gonna waste a lot of time. Okay, we've seen that the sec can't work because it can only work if it's x squared is first, minus a number. Simultaneously, we think about the hyperbolic functions because the hyperbolic functions deal as the chief identity. It's cosine squared minus hyperbolic sine squared. This is the chief identity. Okay. If this is the chief identity, cosine squared minus cos squared minus hyperbolic sine squared. Okay, this one produces the rest of the identities we need. But we can divide this one. Okay, so for example, like this or that. Okay, it doesn't mean you can use only trigonometry, but you can also use hyperbolic functions, not only like trigonometric functions or what you call the secular functions, but could also use the trig functions. Let's come to this one. Cos squared minus hyperbolic sine is 1. Want to see if this can work. What substitution can work here? So what you do is you divide this one by, you must divide this one by a variable so that it gives you 1 minus. It gives you 1 minus. Right, so, for example, if you divide this one by the cos squared, or even the hyperbolic sine, if you divide by the hyperbolic sine, maybe not familiar. If you divide by the cos, it's going to be 1 minus the tanh squared, the hyperbolic tan, divided by the cos, and then it becomes the sec squared, x. Okay. Now, it means that here you can also use the hyperbolic tan. It's going to give an answer. It's going to look different, but it's correct according to this identity. 1 minus hyperbolic tan is the sec squared. Okay, but you can see in the material, the answers there, they used the sign because the answer in particular for 2a, okay, they used the sign. Okay, because you can see it's arc sign there as part of the answer. Move forward. Okay. So I was just trying to weigh in on the other substitutions you can use. You can use hyperbolic or you can use trigonometric. Okay, because in the end, the most important thing is that the integral should dissolve to something simpler that we can integrate. Of course, that we can integrate with ease and great simplicity. We proceed. Now let's come to this. We get exactly this. Let us pause to say, let's leave out the limits of integration totally. Okay, it's allowed. So that we just focus on the integration part. And then when the integral is done, then we plug in the limits. Otherwise, we might need to change. We might need to like keep changing the limits of integration. Not very nice. So let's first do the integral. The examiners understand this. When they mark your words, they know the student was first doing the integration. And then the substitution would then follow later. We're back to do this question. So the one that can work here, because it's a number minus x squared, is the sign, but it is x squared minus a number, then we use the secant. Okay. Now, we're back. I want us to therefore take this integral here. What is dx? Dx is 4 cosine theta. 4 cosine theta d theta. Okay. Okay, then we have x, 4 sine theta. We have 16 minus 4 sine theta. Okay, yeah. The x is 4 sine theta. You put it here. In the place of x, you put 4 sine theta. But there's another x there. But this x is squared. So you're going to square the 4 sine theta. In the numerator, you're going to have 4 cosine theta d theta. Check. You square the 4. It becomes 16. You square the sine, becomes sine squared. Okay? This one is 16 minus, you square the 4, you have 16 sine squared theta. And then d theta. Four cosine theta d theta. And then you have 16 sine squared theta. Here you would have the square root of 16. You take out the 16 out, and then you have 1 minus sine squared. 1 minus sine squared is the square root of cosine squared. Theta. Okay? Then we have this. We have the integral of 4 cosine theta d theta. We divide by, okay, then we check the other one. Okay, and then you have 16 sine squared theta. Right, and then the square root of 16. The square root of cosine squared. D theta. 4 cosine theta d theta. Okay, then you have 16, but the square root of 4 is what? The square root of 16 is what? It's 4. So let's first write 16 sine squared theta, but it's multiplied by 4. Then you also have the square root of cosine squared is just cosine theta. Like so. And then let's check out. Okay, we can simplify this here now. Like cosine theta cancels cosine theta, the 4 cancels out. And then we're just left with the 16 in the denominator, giving us 1 out of 16. And then we have the integral of 1 over sine squared d theta. Like this. We have 1 out of 16 the integral. What is 1 over sine squared? It's cosecant squared d theta. Okay. Right, so we continue. What is the integral of the cosecant squared? You need to think about this. But now this depends on the derivatives. So the integral, to remember the integral of this, you need to remember there's a function whose derivative is cosecant squared, and that function is what? Is the cotangent, but it becomes negative. Okay, because you remember that the derivative of the cot of theta, okay, I'm just remembering this. Okay, I'm just writing so that you can remember this. The cot is cosine theta over sine theta. Okay, the derivative of the top is minus sine theta. Minus the top, the derivative of the sine is cosine theta divided by the sine squared. This would give us negative sine squared plus cosine squared theta. Okay, sine squared plus cosine squared theta, then you have sine squared theta. Sine squared plus cosine squared is the 1, giving us 1 over sine squared theta. 1 over sine squared theta is what? Cosecant squared theta. So this is minus cosecant squared theta. Minus cosecant squared theta. Okay, in a nutshell, we are saying that the derivative of the cot of theta is minus the cosecant squared. Okay. That is the derivative. So if you integrate in cosecant squared, it becomes minus cot theta. Minus cot theta plus c. Then you have the cot. So now we just need to replace the theta. Okay. So now to replace the theta, you would have the following, for example. Okay, so we have the cot. Okay, let's write cot theta. But again, the cot theta, we need to remember what we did here. What did we do? You see, in the beginning, we had the following. In the beginning, we said x is 4 sine theta. We said x is 4 sine theta. But here, because the 4 was because of the 16. We put 4 so that when you square 4, it becomes 16. Okay. Now, what is the theta here? Arc sine x over 4 is theta. Okay, because x over 4, then you get that. Theta is arc sine x over 4 plus c. Okay, good. We're back in business. We are back in business. Meaning that if ever you have the integral from 2 to the square root of 2, then 2 to the square root of 3, dx, you divide by x squared, the square root, 16 minus x squared. What is this integral here? This integral is minus 1 over 16, the cot. Minus 1 over 16, the cot. Then arc sine of x over 4. Okay, this is the integral. Then you must integrate from 2 to the square root of 3, 2, from 2 to the square root of 2 to 2 to the square root of 3. 2 to the square root of 2, 2 to the square root of 3, dx. X squared, the square root, 16 minus that dx, minus 1 out of 16. The cot. Arc sine of the x. 2 to the square root of 3 out of 4. Okay. And then, okay, you can put some bracket here like this. So, yeah, you put the 2 in the place of x, 2 to the square root of 3, and then you put 2 to the square root of 2. Okay. Okay, let's take a look at this one. So it becomes the cot of the arc sine. Okay, 2 out of 4 becomes the square root of 3 out of 2. Okay, arc sine, you see, arc sine, the square root of 3 out of 2, you can get it on a calculator. It is exactly 60 degrees, or pi over 3 radians. Then you have the cot. Arc sine here, the square root of 2 out of 2. So 2 to the square root of 3. Dx divided by x squared, the square root. Minus 1 out of 16. Okay, let's continue, please. Okay, we just need to get this one. So this becomes the cot. Like arc sine the square root of 3 out of 2 is like 60 degrees, or is pi out of 3 radians. Cot. We're using radians here. The arc sine of the square root of 2 out of 2 is 45 degrees. 45 degrees, pi over 4 radians. Minus 1 out of 16. The cot of this, obviously one is going to say there's no cot on the calculator, but we can write it as 1 over the 10. 1 over the 10 of pi over 3 minus 1 over the 10 of pi over 4. So you have 2 to the square root of 2, 2 to the square root of 3. Six minus that. Okay. So it's minus 1 over 16. 1 over the 10 of pi over 3 radians minus 1 over the 10 of pi over 4 radians. Like so. Okay, we go back to the triangles we know from school. There's a triangle like this. For the pi over 3, pi over 6, pi over 3, 2, the square root of 3, 1. Okay. Square root of 2, 1, 1. Pi over 4, pi over 4. 2 the square root of 2, 2 the square root of 3. X squared, the square root of 16 minus x squared. Okay. Now, what is the 10? SOHCAHTOA. SOHCAHTOA from school. So that the 10 we know very well. The 10 of pi over 3. Pi over 3 is this one. So the 10 is like opposite of adjacent. Opposite of adjacent. So opposite of adjacent becomes the square root of what? Becomes exactly the square root of 3 here. The tan of pi over 4, is this one, which is opposite over adjacent. Opposite pi over 4 is 1, adjacent is 1. So it's a 1. Okay, so we have this. We have this. Right, so the minus 1 over 16 multiplies negative 1, giving us what? Giving us 1 out of 16. Minus, okay. This square root of 3, it's minus 16. It's minus 1 over 16, the square root of 3. But this one you can multiply by square root of 3, square root of 3. 1 out of 16 minus the square root of 3 divided by, okay, square root of 3 plus square root of 3 is 3 times 16, which is 48. Which is 48. Which is exactly 48. So it is 1 over 16 minus square root of 3 out of 48. And that's the answer. So any question? So in other words, it proves that our substitution is correct because this answer is the same as what is in the TAT. This answer is correct as the answer in the TAT. And then now we do the next one, we do part C. Okay, once again, this discussion is recorded for control and quality purposes, and you'll have a chance to, view it again. Okay, we're right back. With the integral of the square root of 1 plus 4x squared divided by x dx. Okay. So we continue. Let us look at this one. This one now is an interesting one because we have the 1 plus 4x squared. You see, whenever it's a plus, what do? We use 10. But doesn't mean 10 is the only one, but 10 is the most popular. But now you need to look at it very carefully because you must write everything as a perfect square. Because there was you see, the last two problems were easier. Well, they followed the same type of reasoning. They had both the x squared as the quadratic under the square root. But at this pointer, you have the following thing. We continue. We continue. Now let's take a look. This one, to make it easier, can be written like 1 plus, okay, want it to be perfect square here, 2x, and then you square it. And then you divide by x and then dx. So you let 2x be equal to 10 theta. Let's find the derivative. 2 dx is the derivative of this, which is sec squared. Theta d theta. Okay, so I don't want to say we're jumping too much here. I want maybe to show a trivial step because we want this 2x to be 10 theta. That's what we want. Note that the 10 theta is having, we're always very cautious of the fact that it is a number the number here is this number. The 1, it's there. So this 2x must be 10, but if this was a 9, it's going to be messy because we're going to say 2x is the square root of the 9, which is going to be a 3, 10 theta. So it's going to be a little bit messy, but it's easier because it's 1. Okay. Right, because now you always multiply, like in the x, we multiplied. Here we said let x be 4 sine theta. Here we said let x be 3 sine theta. Okay. Okay, here we have, we can solve for x and have to half 10 theta. Dx are 1/2, which is sec squared theta d theta, like this. Okay, let's check. Take a look and see that at this point we have this one, which we can write as the square root 1 plus 2x, and then you square it. And then it is divided by x dx. This is the integral of the following. 1 plus, what is 2x? Tan theta. Okay. So in the place of tan theta, or in the place of 2x, we put tan theta. Then we square it. X, what is x? X is 1/2 tan theta. And then what is dx? Dx is 1/2 sec squared theta. D theta. Half cancels half. And then you have the square root of 1 plus 10 squared. What is 1 plus 10 squared? 1 plus 10 squared is sec squared theta. Okay, let's check. Okay, we're back. The integral. So we have the integral of the square root of 1 plus 10 squared. Half tan theta. Which is sec squared theta. One plus 10 squared is the square root of sec squared theta. One half, which is sec squared theta. The square root of sec squared is sec theta. Okay. Okay, we're right back and we're here. Okay, this is true is because of sine squared theta plus cosine squared theta is 1 from metric, and then you can divide through by the cos squared. So it's going to be sine squared theta divided by the cosine squared theta, and then divide cosine squared theta by cosine squared theta. You divide 1 by cosine squared theta. Okay, 10 squared theta plus 1, which is secant squared theta. Like that. So that there's a 1 plus 10 squared is secant squared. That's why always when it's 1 plus, we use 10 squared. Yeah? Okay, the couple of things that are interesting here, we can quickly see. We can like the cancellation of these things. Right, we cancel those things, and what do we get? So we are back like that. Tan theta sec squared. D theta. One over cosine theta divided by sine theta over cosine theta. 1 over cosine squared theta d theta. Okay. Okay, let us check this one. Let us check this one. So we're gonna continue up here. Okay, we take a look. This cosine divides this cosine, leaving us with the integral of 1 over sine theta. Okay, and then this is 1 over cosine squared theta, d theta. And then 1 over sine is cosec. Sec. 1 over cosine squared is sec squared theta. Okay? Right. Right. This is what we get. This is what we get. What we get. Okay, there are a couple of ways to look at this. There are a couple of ways to look at this. Okay, this one, you can also look at it this way because here is 1 over 10, which is the cot. The secant cubed theta, d theta. Okay, we have this. Okay. I was saying here it's just only the cot. Okay. Because sec times sec is sec cubed. And then the 10 here becomes exactly 1 over 10 is the cot. And simultaneously, this simplifies like this, but it also simplifies this way because it's cos over sine and becomes this. So now, obviously, you have to look back and be like, which one is easy to evaluate? If you let u to be the secant, the derivative of the secant is sec 10. It's not going to work. If you let u to be the cosecant, the derivative of the cosecant is what? Right, the derivative of the cosecant becomes minus cosecant the cot. So, not the best. If you look at this one, if you let u be the secant, the derivative of the secant is what? The derivative of the secant becomes this secant times the cot. Okay. It becomes the secant times the tangent. Excuse the secant times the tangent. So now you need to think and obviously decide on this particular one, but you are just halfway through. You are exactly halfway through. We take a look at this and we reason together. We take a look at this and we reason together. So this one requires integration by parts. Okay, it requires integration by parts. So you're going to use integration by parts because substitution is not immediately yielding the result. So we're going to take this presentation. It's much simplified than that. In other words, we are dealing with number C or letter C. Right, dealing with letter C, we would then first things first realize that at this point, to do this integral here, in C, you would have exactly the following. You'd have exactly the following. So, could remove this. Fine. We're going to use this one. Okay. So this integral here, cosec theta secant squared theta, d theta. Okay. We have exactly this. Okay, take a look at this. We're going to use integration by parts because we know the integral of sec squared. So we're going to use the fact that now we know the integral of sec squared, so we use integration by parts. And so, but we know from the integration by parts formula that the integral of u dv is uv minus the integral of v du. Okay. With that mentioned, now we're going to choose which one is which. But clearly, we know the integral of secant squared as much as we know the integral of the cosecant. We know both integrals here. So, okay, it's fun a little bit. But it's easier to integrate the secant squared. Its integral is nicer. Okay. The integral of the cosecant is not very nice. So, okay, you'll see why. But yeah, you know them from the formulas. So we're going to let, okay, because we can easily integrate the secant squared, then we will have to differentiate the secant. So we would let the v, you take the v to be the secant squared. Right, so we take the v to be the secant squared. And then you would have the, if the v is the secant squared, u is going to be everything that remains, which is cosecant theta. Now, this one, now you find the integral of this, giving us v. The integral of the secant squared is what? It's the tan theta. Du. The derivative of the cosecant is what? It's minus cosecant theta, the cot of theta, d theta. So the integral of this becomes exactly uv. It becomes u, which is the cosecant, and v is this one. So uv is cosecant of theta tan theta minus the integral of v tan theta du. Du is this one minus cosecant theta cot theta d theta. Okay. This is exactly the same as, okay, cosecant theta tan theta. Negative by negative is plus the integral. Okay, now this is sine over cosine, cosine over sine. So the tan cancels out, and then you have the integral of cosec theta d theta. We're done with this. Okay, now this is not, we just have the integral of the cosecant to do. So this is quite a heavy module. They don't joke here. So you have cosecant, see how lengthy this problem is. It's cosecant theta tan theta. What is the integral of the cosecant of theta? The integral of the cosecant of theta. So you think about the integral of the, okay, we can always derive it, but yeah, remember I did a video on this one a couple of months back on YouTube. I was just investigating the integral of these. Right, so now you have, okay, I'm going to just write that one down. The integral of the cosecant. Okay, there are two integrals like these that are very popular. There are many. Okay, but the most popular is that the integral of the cosecant is what? Okay, the integral of the cosecant is plus the ln of the cosecant of theta minus the cotangent of theta plus c. So this is the answer to the problem. But again, this is not yet the answer because we don't know. Well, the given problem was in terms of x, so we must bring back everything. So we're back. So we're going to finish everything here. Now, at this point, we know that 2x is, we said in the beginning, 2x is tan theta. Everything has been done through the substitution that 2x is tan theta. Right, so we have 2x equals tan theta. Okay, this is integration. It can be hectic sometimes. Okay, so how do you learn this? You repeat during your own leisure. You just try this one, check the videos of the solutions we've done, and make sure that you really can sort of, do the tasks. And then if you can do the tasks, then you're gone. Okay, right. So this is equal to cosecant theta tan theta. Cosecant theta tan theta. Uh-huh. Cosecant theta tan theta plus the ln of cosecant minus the cot. Plus the ln of cosecant theta, yeah, minus the cot. Plus c. But if, yeah, okay, just remove these things that is stepping the 3 sign. We wrote them earlier. But now we just need to do everything here. And to do this with ease, then, yeah, we can use a triangle. Right, you can use a triangle. Just use some triangle, then you can get quickly the rest of the other trigonometric things. Trigonometric ratios. Okay, tan theta is 2x. So if this is the angle theta, tan theta, we use SOHCAHTOA. The tangent is opposite over adjacent, which is opposite over adjacent. And then this one is opposite over adjacent. And then from this, and then this one is 1 plus 4x squared. Which is 1 plus 4x squared. 1 plus 4x squared. One plus 4x squared. Okay. What is the cosecant of theta? You come here. Cosecant of theta can be obtained here. Okay. Now, if you remember, therefore, the reciprocal of this one of the side is the cosecant. The kosher cow. Kosher cow. Kosher cow. Kosher cow. So that the cosecant is what? The cosecant, the reciprocal of this is hypotenuse over opposite. So hypotenuse over opposite, it's going to be 1 plus 4x squared over the opposite, 2x. The tan becomes opposite over adjacent. The cosecant becomes what? We've already seen that cosecant is the reciprocal of the sine. If the sine is opposite of hypotenuse, then the cosecant we've already got is 1 plus 4x squared. You divide by 2x minus. What is the cot of theta? Okay, the cot of theta, you can view it as 1 over tan. But the cot is the reciprocal of the tan. So it is adjacent over opposite. The tan is opposite of adjacent. The cot is adjacent over opposite. So that you have the one here and the cot is adjacent over opposite. Okay, this is the answer. Okay, so you can see that this answer is the same as the one that they gave in the TAT, but we need to simplify this one a little bit. Okay, but there are two integrals that you can use here. They used another formula for this in your school. So they use the formula because, see, there's a plus there. They use the formula that the integral of the cosecant of x or theta is negative the ln minus the ln. So see, there are two of this. So we're going to use both. Wait a minute. They use the integral that this one is actually minus the ln of cosecant theta, the cot of theta plus 1. Okay. Okay, let's do it like in your school. So that now the integral of the cosecant, okay, I must state that up front. So these are the same things, but you see the cosecant has many integrals. Right, so the integral of this one is minus the ln of the cosecant plus the cot. Okay, these things can be proven, but these are all correct. They look different. Okay, now when you have the cot here, then you put a minus here, and then here you put a plus. I want it to be exactly the same as the one the TAT. But yeah, the answers are both correct. So you'd have the minus here, and then here you have a plus. Okay, then you have a plus here. Okay, this is exactly as in the TAT. So let us do it in blue color to conclude. Now this one cancels, then you have the square root. 1 plus 4x squared. So 1 plus 4x squared divided by 2x plus 1 over 2x plus c. If you check, this answer is exactly the same as the one in the TAT. Hey, this is heavy. Okay, it's a bit more reasoning, but yeah, you can see what we've done. And you actually need to make sense of it. You just need to make sense of it. So you're able to see what we've done. Take a moment to reflect and think about these things as we move forward to the next question. We move forward to the next one. Okay, now, this one, evaluate the integral using an appropriate trigonometric substitution, same thing. But this one is going to use the SAC because the x term is first, like x squared minus 9. 16x squared minus 9, so you're going to use the secant here. Right, but now because they played around, they put a 16 and a 9, you need to just be very cunning, and we need these things. Normally, we need the 16 and the 9 to be both 1, but because they have been given that way, then we need to use clever methods. Clever methods. Right, so you continue. You continue. Okay, let's check. Okay, when I do this one it's easy. Because it's a plus with the square, you're going to use the tan. Doesn't matter anything else. Doesn't matter anything else. You're going to use the tan. But, you see, we're given the integral. Four plus 9x squared. Dx. Then you let We'll continue. Let's just do the D. Now, obviously, you need to use the tan here. But now to use the tangents, you need to think, because you must first things first, write everything around the x in the denominator square to be like what? To be like perfect square. Okay, so we have x squared, you divide by 4 plus, then you have 3x, which you square, and then you square. Okay, you can write it like this. Upon careful inspection, we're able to see that we can only learn 3x. Right. Okay, we continue. So we want this 3x to be 10, just 10. But there is a 4, and this 4, you must take its square root. Okay, just showing some steps. You must take its square root and then put, this thing must be 10 theta, like this. So once we write this, we are done. Then, with 3x, the square root of 4 becomes a 2 10 theta. And then everything else is easy. To find the derivative of this, it is 3dx. The derivative of the tan is the sec squared theta d theta. Okay. Okay, obviously you'll say that we need a dx here. So that in the end, then the dx becomes 2/3 the sec squared of theta d theta. Take a look, and we are in business now, because we have the integral from 0 to 1 of this one. What is x squared? X is this, yeah, check. Is 2 10 theta out of 3. 2 10 theta out of 3, which is 2 10 theta out of 3. What is dx? Is 2 over 3 the secant squared. Okay. I'm sorry I lost you. I'm sorry I lost you. I'm sorry I lost you. But this is recorded for control and quality purposes, and you're going to have a chance to watch this. Right. Sorry I lost you. Oh, leave the limits of integration in the meantime, because we're changing now to a new variable. So please make sure you use a new limit of integration. 4 plus, what is that 3x? 3x is 2 10 theta squared to the power 3 out of 2. Okay, we continue. In the place of 3x, what did you put? 3x is 2 10 theta. So in the place of 3x, we put 2 10 theta. And then we square it, and then there's a 4. And then the x itself becomes what? The x itself becomes like 2 10 theta, and then you square it. And you have the dx. The dx is 2/3 sec cubed. We're good. Which is exactly 2/3 squared. 2/3 squared, and then there's another 2/3. 2/3 squared, there's another 2/3, which is going to be 2/3 cubed. Okay, once again, this is recorded. 2/3 cubed. So you're going to have 2/3 cubed, then you have the 10 squared, and then the sec squared. And then you have the sec squared. 4 plus 4, 10 squared. D theta. So now you can pull out some common factors here. You can pull out the 2/3 cubed. You have the 4 raised to the power 3 over 2 in the denominator. And then we have the integral of the 10 squared. And then when we have the 1 plus 10 squared, 1 plus 10 squared is sec squared from high school. Raised to the power 3 out of 2. We have 2/3, you cube it. 4 is 2 squared. 4 is 2 squared. The square cancels, giving us 2 cubed, and 2 cubed is 1/8. The integral of the 10 squared, sec squared. You divide everything by the 2 cancels, giving us the sec cubed. Sec cubed. Sec squared cancels a single sec. Okay. Check. So now this one here is like 2 cubed. 2 cubed is 8. 8 cancels 8, giving us 1 out of 3 cubed. 3 cubed is 27. 10 squared. And then sec squared cancels here, giving us sec theta. And then the sec theta becomes cosine theta d theta. One out of 27. The integral of. Now the 10 squared is sine squared over cosine squared. And then there's cosine squared, there's cosine theta d theta. Cosine theta is going to cancel one factor, giving us 1 out of 27, the integral of sine squared theta divided by cosine theta d theta. So now you have the integral of this one, which is exactly sine theta over cosine theta, which is cosine theta d theta. Okay, now sine over cosine is what? It's 10 theta. And then 1 over cosine is what? 1 over cosine is sec theta d theta. Sectan. Sectan. Right. The integral of sectan is the sec. Yes, is the sec, because the derivative of the sec is the sectan. So this is 1 over 27 the sec. One over 27 the secant of theta. So the derivative of the secant is sectan. Okay. So this is the answer, but you just need to beautify it. In other words, we are saying the integral, we leave out the limits. We have x squared, you divide by 4 plus 9x squared. to the 3 over 2 dx. One out of 27, the sec of theta plus c. Okay, sorry, we continue. We remember what we said. We said that 3x by our substitution for this one was equal to 2 tan theta. And then we use some triangles to easily get these things. So I'm going to use a triangle like this. If this is the theta, the tan theta becomes 3x out of 2. Tan theta becomes 3x out of 2. So that whenever you have this one, tan theta is opposite of adjacent. The square roots. 9x squared plus 4. One out of 27.
Sorry.
Yes, please.
So okay, no, it makes sense. Okay, like I was going to ask that if you're constructing the triangle, like how did you get the r, the hypotenuse?
Oh, okay. Yeah, we use Pythagoras. That's fine. Okay, let's just discuss it. Let's just discuss very briefly. Yeah.
The from the fraction thing.
Okay, let's just do it together. Okay, just 1 second. Let's just discuss the triangle for just a split second. And then move on because I want us to do the next question as well. In this particular, these questions are a bit long. Okay, right. Now, we said 3x is 2 tan theta. And then the tan is 3x over 2. And then we use SOHCAHTOA. And now the tangent is opposite of adjacent. So if this is theta, opposite over adjacent is this. So that this one becomes the square root of the 2 squared. It's a 4, and you square this one becomes 9x squared. Like this. So when you come to the secant here, what is the secant? Obviously, you can view the secant as 1 over cosine, but SOHCAHTOA. Shakao for the reciprocal functions. So the secant is the reciprocal of the cosine because the secant is 1 over cosine. So that is hypotenuse of adjacent here. And therefore, it's going to be, because now we're changing back to the variable x, so we use the triangle. So now it is hypotenuse of adjacent for the secant. Hypotenuse is this one. Adjacent is 2. Hypotenuse of adjacent, which is 1 out of 2 times 27 is 54. 4 plus 9x squared plus c. Okay. Now it appears that, okay, we check because now we have written, okay, but we're not done yet. Let me write it here. 2 times 27 is 1 out of 2. The 2 times 27 is 54. But the answer must be numerical because we have limits of integration. So we just need to plug those in because we're just doing the integral without what? Without the limits. So now we're going to just use the limits. Plug in the limits and then we get the answer. Let's just do that. Okay, meaning that now we have the integral from 0 to 1 of the x squared, all divided by 4 plus 9x squared. 3 out of 2 dx. 1 out of 54. 4 plus 9x squared. You integrate from 0 to 1. You plug in the 1. So it's 1 out of 54. If you plug in the 1, the place of x, you'll have 4 plus 9. The x is 1. You square this minus. You have 1 out of 54. You put the square root of 4 plus the 9, and then you put the 0. 4 plus 9, 13. Square root of 13. Minus. This one is the square root of 4. The square root of 4 is what? It's 2 over 54. 2 divided by 54 is 27. So that the answer here can be written as the square root of 13. Right, the square root of 13 over that. I'm going to just check, please, the answer, obviously, in the chart. But it appears that we have exactly what here? We have exactly the square root of 13 out of 54 minus 1 out of 27. Okay, check this. Must be pretty much, it must resemble sort of the thing. Okay, I'm just checking in the chart if it is the same thing. And then we're going to do part E. Then we're going to do part E, part E, part E. So now we're doing D. We're doing the D. Okay, so, okay, just 1 second. I need to check something here. With the D, just 1 split second. There's something I need to check with the D. And then so that we can see. Okay, in this case, we have the integral 0 to 1. X squared which is 4 plus 9x squared to the power 3 out of 2. Okay, like that. Okay, there's something I need to check here. Okay, there's something I need to check here. Okay, just 1 second. Something I need to check. If we simplify it correctly here, there's a small error. As far as I can think, this is cubed. This one, 4, is going to be 2 to the power that, which is 2 cubed, which is 8. And then this is x squared, which is cubed in the denominator. But this one is x squared here in the top. Okay, there's a small mistake I need to sort of identify. Okay. Let's see. Right, we have 3x equals the square root of 4, and then everything is above board. The derivative of the 10 is x squared. And then now you come here. Okay, you have the x. 2 out of 3 square roots. Dx is 2 over 3 is x squared. 4 plus. The x. The x is 2 tan theta over, let me see. Okay. What is, we had the 3x squared. So the 3x is 2 tan theta. 2 tan theta. Yeah. Then you square it. Looks all fine. Okay, I'm trying to see, there must be a small error. So you'd have the 2 over 3 squared, and then this 2 over 3 here is going to give us a cube. And then 10 squared, 6 squared. And then you have 4 plus 2 tan squared. 3 over 2. 10 squared, 6 squared. The 1 plus x squared. This 3/2, yeah? This one is 2/3, you cube it, and then this one is 2 cancels from the 2 squared, and then you have 2 cubed, which is 1/8, 10 squared, sec squared, and then this one, the 2 cancels giving us sec cubed d theta. Check. Okay, I'm trying to see. 2 cubed is 8, 8 cancels giving us 3 cubed, 27. 10 squared, and then sec theta, which is cosine theta, d theta, 1/27. Sine squared theta over cosine squared theta. Now the cosine theta cancels out, giving us 1 cosine theta in the denominator. Sine squared theta over cosine theta, d theta. Okay, I think there's a mistake there. The mistake is here. Right. I just seen the mistake. I think I've put an extra cosine theta. Right, because this is like, instead of the 2 sines, we put 2 cosines. Because this is sine squared. Should have been sine squared, but I'm wondering why. It was put 2 cosines there. That became the error. Oh my goodness. So that now you have the sine squared over cosine squared, which is what? Which is here, cosine theta, and then it is 1/cosine theta. Check that. Okay. I'm doing the same thing. Okay, so it means that the top is going to be sine over cosine times sine theta. One over 27. Now you have the sine and sine like that. You can write it like that. But what I want to write here is that we can write these as the sine squared divided by cosine squared. Yeah, it's okay like that. But what substitution can we use here? Okay, it can't help to change it to other things. But we can just use substitution. So in the meantime, I'm going to remove all this because there was an extra cosine theta that created this. So now we're going to do that one. We might need to use integration by parts. Let's see what we're going to get. All right. So, okay, went through this journey for nothing. Just imagine. Okay. So, right. So now I want us to get back to this. So we have 1/27. The integral of the sine squared over cosine theta. D theta. Let u. Okay, now we need to integrate these. And to integrate these now, if you let u to be sine theta, then the derivative du is cosine theta. D theta. Which is u squared, and then you have cosine theta. D theta, what is d theta? D theta becomes du over cosine theta. 1/27. The integral of u squared over cosine squared theta. Cosine squared theta is what? Okay, you already know sine here. Cosine squared theta is 1 minus sine squared theta. 1/27. U squared. 1 minus sine squared theta is 1 minus u squared. D theta is what? Let me see. Let me see. Because this was d theta is du of cosine theta, yeah? Okay, so you see now, this is du. Wondering why that is the case, but this is du. So that you have 1 minus cosine squared, rather cosine squared is 1 minus sine squared, which is 1 minus u squared, and then this is du. Partial fractions. Okay, this one becomes partial fractions. So, but not quite partial fractions yet because the degrees are the same. So if the degrees are the same, we use division. U squared you divide by minus u squared plus 1. Can write as minus u squared plus 1. U squared divided by minus u squared is minus 1. You multiply minus u squared minus 1. Aha! This is exactly what? Let me see what we're getting here. We're dividing u squared by minus u squared plus 1. So you divide u squared by minus u squared, you get a minus 1. Okay, let's get the signs right. And then when you do this, you do the multiplication. Okay, check it out. You multiply this minus u squared by the minus, it becomes plus u squared. Minus 1, and then you subtract this, you get a 0, and then you get a 1. Okay. So that you have 1 out of 27. Okay, now the integral of, if you have u squared divided by this, u squared divided by 1 minus u squared, can write it here. U squared divided by 1 minus u squared is the quotient. Minus 1 remainder, 1 over 1 minus u squared. Okay. Minus 1 plus 1 minus u squared du, which is minus u over 27. One over 27, 1 minus u squared. Okay. Now we just use partial fractions for this one. Okay. We just use partial fraction for this one. Yeah, it's exactly what we need to do. To integrate the 1 minus u squared, we can use a trig substitution, but the easiest is to use partial fraction decomposition. We already have the following. We have the integral of this one, which is minus, yeah, you can add a C1 if you want. Minus u out of 27 plus the integral. Okay, plus 1 over 27, the integral of that. 1 out of 27, the integral of 1 over 1 minus u squared. Du. Take a look. Okay, 1 over this. 1 minus u squared is 1 over 1 minus u, 1 plus u. 1 minus u, 1 plus u. 1 over 1 minus u squared. Yeah. But the 1 over 1 minus u squared is 1 minus u, 1 plus u. You multiply out. Multiply by both. You get 1 equals this one, 1 plus u, b, 1 minus u. A plus b, a minus b. Okay. A plus B is 1. A minus B is 0. You add these two up, you get 2A. A plus A is 2A, 1 plus 0. You get that A is 1/2. Then if A is 1/2, this one says that A is equal to B. So if A is 1/2, also B is 1/2. By partial fraction decomposition, it means that 1 over 1 minus U squared. Half divided by A minus U. Half divided by 1 plus U. Minus U out of 27 plus 1 out of 27. The integral of 1 over 1 minus U squared is the same as by partial fraction decomposition this, and it is 1/2 divided by 1 plus U du minus U over 27 plus 1 over 27, and then it becomes, so you're going to have 1/2 the ln of 1 minus U plus 1 out of 27. Then you also have 1/2 the ln of 1 plus U plus C. Okay. Now we're done with the integration. So it's minus U over 27. Then this one, 1 over 27.5, it's a constant. You can pull it out. So, but 27 times 2 is 54. Then we have the ln of 1 minus U plus the ln of 1 plus U, like this, and then plus C. We got minus U out of 27. We got minus U over 27, and then we got exactly 1 out of 54, the ln of 1 minus U, 1 plus U. The ln of 1 minus U, the ln of 1 plus U, and then we add C. Minus U out of 27, and then 1 out of 54, the ln of 1 minus U divided by 1 plus U plus C. Look. Okay. Okay, but this was not in terms of U, this. Okay, so we did a lot of substitutions here. But first, the U is sine theta. U is sine theta. So now, wherever U appears, we know it is sine theta. So let's do that. Wherever U appears, it is sine theta. So this one is minus sine theta divided by 27 plus 1 out of 54. The ln of 1 minus sine theta divided by 1 plus sine theta plus C. Right? But still, the problem was in terms of X, so we must bring X back. What was the correct substitution that allowed us to move from X to theta? Right, we said that 3X was 2 tan theta, or X was 2 tan theta over 3. Yeah, 3X was 2 tan theta. 3X equals 2 tan theta. 3X is 2 tan theta. Yeah. Okay. So now we need to do the triangle. And then we can get everything we want. Okay, so we back to the triangle, because this triangle is going to come from the fact that 3x out of 2 is tan theta. Theta is this one, which is opposite of adjacent. Opposite of adjacent. 9x squared plus 4. Okay. Okay, so which is minus. what is this? Minus 1 over 27. What is sine theta from this triangle? Okay, we have minus 1 over 27, but sine theta, we use SOHCAHTOA. SOHCAHTOA. Okay, the sine is opposite of hypotenuse right here. Opposite of hypotenuse is 3x over the square root of 9x squared plus 4. Which is exactly this. Okay, check that this one is going to be opposite of hypotenuse. By the sine theta. 1 over 54 the ln. Okay, so we have this. Okay. So this one now you can write. Okay, it's not very nice, this. Because the sine, look at the sine alone. It's this big thing here. Which is 1 minus, what is the sine? It is 3x over the square root of 9x squared. So we continue. We continue. We continue. Okay, so it is this one, 9x squared plus 4. One plus 3x over 9x squared plus 4. And then you add a c. Which is now, here you have this answer. This is the answer. Let us write the answer properly. Let us write the answer properly. And then you have x squared divided by 4 plus 9x squared. 3 out of 2. Which is minus 1 out of 27. The 3x over that. Square root of 9x squared plus 4. The ln. 1 minus over 1 plus. 1 minus the 3x. 1 minus 3x over the square root of 9x squared plus 4. Okay. Okay, look, this is what we get. Okay, let us leave the limits of integration out a little bit. In the meantime, if we leave the limits of integration out, we add the arbitrary c, constant of integration. Okay, I want us to continue to simplify this a little bit before we substitute so that we do not have a very cumbersome thing to do. And then this is the x. Okay, 3 goes up in time 27. It goes minus 1 over 9. X over the square root. 9x squared plus 4. So you multiply by this, which is actually the square root of 9x squared plus 4. 3x divided by the square root of 9x squared plus 4. Plus 3x. So we continue. Okay, let's check. We check. So that now when we integrate this one, we integrate from 0 to 1. And then you integrate here, which is minus 1 over 9x divided by the square root. 9 that plus 4 plus 1 out of 54, the ln of this one. The square root of 9x squared plus 4 minus 3x divided by the square root of 9x squared plus 4 plus 3x. 0 to 1. The integral from 0 to 1 x squared divided by 4 . Okay, look. Minus 1 over 9. Give the square root. 9x squared plus 4. Okay, just check. Plus 154. The ln. 9x squared minus 3x. 9x squared plus 4. Divided by 9x squared plus 4 plus 3x. Like this. The integral from 0 to 1. X squared divided by 4 plus 9x squared. Okay, so okay, let's check this out. Minus 1 over 9, then you plug in the 1. Going to be 1 over the square root of what? 1 over the square root of 9 plus 4 is 13. Plus 1 over 54. You plug in the 1. It's going to be the ln of the square root of, if you put in 1 the place of x, 9 plus 4. 13 minus 3x divided by the square root of 13 plus 3. Ah. Okay, minus 3 plus 3, because the x is 1. Because the x is 1. Minus, plug in the 0. 0 here is going to be 0. Going to be 0. 1 out of 54. The ln. If you plug in the 0 in the place of x, it's interesting. That is very, very interesting. Okay, if you plug in the 0 in the place of x, what will this become? Okay, it's a bit tricky. Then you need, because now this is going to be like, oh, okay, it's fine. I was worried. But if you plug in the 0, then it's going to be 0, and that's going to be 0. And then we have the square root of 4, which is a 2. And this is going to be a 2. And then everything becomes a 1. We're good. Right, so x squared divided by 4 plus 9x squared, 3 out of 2. Minus 1 over 9. The ln of 1 is 0. Okay, then we have this one. Okay. Okay. Okay, this is sort of part of the answer we're saying, but you need to rationalize this. To remove the square root from the denominator, so you have the square root of 13 minus 3 divided by the square root of 13 plus 3. You multiply by, okay, so you need to change these things. You need to change it to 3 plus the square root of 13. 3 minus the square root of 13, you divide by 3 minus square root of 13. Okay. Ln 1 is 0, so yeah, we have that. So that whenever we have the integral from 0 to 1 of x squared, you divide by 4 plus 9x squared, you raise it to the power 3 out of 2 dx. It is minus 1 out of 9 the square root of 13. Minus 1. Out of 9 the square root of 13. Plus 1 out of 54. Okay, then now we have this one. In the denominator, you have this difference of 2 squares. It's going to be 9 minus 13. The top is going to be exactly this one here, which is the square root of 13 minus 3. 3 minus square root of 13. Three minus the square root of 13. Four plus 9x squared, then we have 3 out of 2 dx. One out of the square root of 54, the ln. Okay, then factor out the negative. Minus the square root of 13 here, and then 3 minus the square root of 13. 9 minus 13 is a minus 4. Minus 1 over 9 the square root of 13 is exactly the answer they got in the TAT. Then we have 1 out of 54. Okay, check this out. Okay, this might just simplify beautifully. Just check this and see what you're getting. So this is going to be exactly what here? This one is going to be negative. 9 minus 2 the square root of 13 plus 13. You divide by minus 4, like this. Okay. What is 9 plus 13? 9 plus 13 itself is exactly the same as what? Okay, anyway, you don't need that. You don't need this. But there's something you need. What do you need? This is a perfect square, this. And also 4 is a perfect square. At that point, it's enough to then say you got perfect squares. And so you can write here 1 out of 54. The ln of. Negative and negative cancels out, giving us plus. So you have the ln of 3 minus the square root of 13 out of 2. And then you square this. Like that. And then you square it like that. Let me see this minus or plus. Just 1 second. Need to check the signs. It's a plus. Why do we have a minus? Uh-huh. Let me see, why do we have a minus? Just a sec. Why do we have a minus? Okay, wait a minute. Why do we have a minus? Minus plus? It doesn't matter, because here we can do it either way. This one, you can have the... Did I do here? What did I do here? Okay, because this one is 154, and we have the product here. And that is the plus. Okay. Okay, we are continuing, please. 2 over the square. So it's going to cancel that out. Okay, because you see, the thing is that here, this is a sum, and the sum must become a product. I'm wondering why. The sum must become a product. So this is therefore going to become the ln 1 minus u, 1 plus u. So now, yeah, minus that. The ln of 1 minus u squared plus c. Okay. Okay, now let's continue. Mm-hmm. Right, so yeah, I mean, this is a sum, so it must be a product like that. Oh, my goodness. So now, so that in the end, we have exactly that. But it wanted to also theta. The theta is opposite of hypotenuse. The theta is opposite of adjacent, opposite of adjacent. You square the 9, and then you square the 3x. The 3x and the 2. Which is 4 plus 9x squared. Okay, we continue. Okay, the u is sine theta. Oops. So the u now becomes sine theta over 27. 1 out of 54, the ln of 1 minus the u is sine theta, which is sine squared theta plus c. Minus sine theta divided by 27. 1 minus sine squared theta is cosine squared theta plus c. Okay, you bring down the 2. This becomes 2 out of 54. The ln of cosine theta plus c. So I'm going to change this. Oops, I'm going to change this. Right, I'm going to change this quickly. We're done, but yeah, I saw that made a quotient out of the sum. The log of the sum is the product. So the sum of logs is the log of the product. Wondering why that became a quotient. But now we're back. Oops. Right, so. Okay, we're right back. We're here. Minus sine theta out of 27. And then you have the 2 out of 54. 2 out of 54 is 1 out of 27. The ln of cosine theta plus c. Okay, check. And then we remember, okay, we're done. 2 tan x, 2 tan theta. Right, opposite socket tower. Opposite over adjacent. Opposite over adjacent, which is 2, and then by Pythagoras theorem, this becomes the square root of the 2 squared, which is a 4, and then the 3x you square it, you get a 9, x squared. Minus 1 out of 27, the sine of theta. Opposite of hypotenuse, yeah? Opposite of hypotenuse is the square root of this. Plus 1 out of 27, the ln of the sec, of the cosine, adjacent of hypotenuse. Like that. Okay. So now we can just be able to do the things we want. The integral from 0 to 1 of this one, x squared divided by 4 plus 9x squared, 3 out of 2 dx. It is this integral, but now you take it 9, 3 cosine times 27, minus 1 over 9. 4 plus 9x squared. The ln of 2 divided by the square root of 4 plus 9x squared. So we have exactly this. The integral from 0 to 1. X squared divided, which is this? X squared divided by 4 plus 9x squared, 3 out of 2. Dx. We come to this. Okay, we have this, minus 1 over 9. Okay. 4 plus 9x squared. Plus 1 out of 27. The ln. 2 over that. 4 plus 9x squared. 0 to 1. X squared divided by 4 plus 9x squared to the 3 out of 2 dx. Right, so minus 1 over 9, then 1 over the square root of 13. Plus 1 out of 27. 2 out of the square root of 13. So if you put in the 0, this is going to be 0. And if you put in the 0, this one is going to be 0. Putting the 0 is the ln of 2 over, if you put in the 0, you have 2. Okay. Yeah, there's an extra term that is playing games here. Let me see. Let me see. There's an extra term that is playing games. There's an extra term that is playing games. I'm going to establish why that is the case. Going to establish why that is the case. Going to establish why that is the case here. Going to establish why that is the case. U squared Okay, I'm trying to check. There's a small error, my goodness. Trying to see where that is. Trying to see where that is because this is exactly u squared over cosine theta du over cosine theta. The theta is du over cosine theta, and this is cosine squared du. Cosine squared is 1 minus sine squared, which is 1 minus u squared. Okay, wait. Okay. You have u squared divided by that. Okay, I'm trying to check what we're getting here. I'm trying to check what we're getting. Getting exactly that, minus u out of 27, 1 out of 27. Yay. And we have exactly that. And now from the partial fractions, we got half. This all looks fine. And then we have these. And then we multiplied the things like that. And then we got 1 minus that difference of 2 squares. Okay, because there's a problem with this term. And then we got 1 minus u squared, and 1 minus u squared, the u is sine, and therefore it becomes cosine squared. And this becomes the ln of cosine squared. And then the 2 out of 54 gives us 1 out of 27. I'm trying to see. Then we have the ln of cosine. And the cosine here becomes exactly adjacent of hypotenuse. So it's this. And then if you put 1, it becomes 2 over the square root of 13. And then you put 0, becomes 2 out of 2. Yeah, okay, wait a minute. There's surely a small error that is here. This term needs to have, inside here, we need to have 3 out of 2 plus the square root of 13 out of 2. Can this be rationalized to that? Let's check, because if you have, doesn't matter, doesn't appear that way, 2 out of the square root of 13, you rationalize by 13 out of 13, and therefore it becomes 2 the square root of 13 out of 13, like that. And then if this is the case, three plus the square root of 13 out of 2. Okay. Yeah, there's something wrong with this term alone. This is fine. Why is it that this is not exactly the same? It has to be the same, because this is a numerical integral. Okay, so I'm trying to see, because see what mistake is there, because otherwise than this here, because the cosine of this is adjacent of hypotenuse. Okay, yeah, there's just a small little error. I'm trying to see that. It might have appeared somewhere when we performed a division somewhere. Okay, just 1 minute. I'm trying to see why that term alone is not working. Okay, why that term alone is not working? Just 1 minute, because yeah, it's strange to me. It's strange. Then I can come back and do the same thing. Just imagine. Because I'm trying to see why it's not working out. So you have 1 minus u squared, minus x squared. Okay. Let me see. All right. Let me see, let me see, let me see, let me see. Okay, these things are the same, but they just behave, but now it's strange. You can imagine that the likelihood is that thing is the same. Okay, that's what I'm trying to now beginning to think, because it might just be the same, but looking different. Let's just check this out. So to check this out, I want to compare numerically. Because I might just be stressing myself something that looks different. This one might be the same as this in terms of the log. But let us check this out. For example, I mean, if you have, yeah, want to check? I want to check. Okay, I want to compare 1 over 27 ln of that, so that I can look at, because I can transform the things, but 2 out of the square root of 13. See now, please. I want to see the answer to this relative to 1 over the ln, because these things, they look a bit different, yet there might be great similarities between them. Just 1 minute. So if you have the ln of the square root of 13 out of 2 plus 3 out of 2. Okay, because this must be this. But now there might be, I need to check this, because if ever we got that, please just a minute. So I want to see why when the 3/2 missing there. Okay, there might be something that is missing. Okay, so for example, we're gonna do 1/27, and then the ln of 2 out of the square root of 13. Okay, if you do that, 1/27, the ln of that is minus 0.02. Minus 0.02. Let's do the bottom one. They look different, but I'm beginning to think you might get to this just transforming this by sign in the integration process. So you have this one out of 27, then you have the ln of, see now time is going, then you have the square root of 13, you divide by 2, and then you add 3 out of 2. Indeed, they're different. 0.04 something. Right, 0.044. Right, what I'm going to do is, I think I'm going to do it when I come back. When you come back in the afternoon, because I'm going to repeat this question. I need to investigate why this must be 3/2 plus square root of 3, 13/2, because, see now, we've gone through so many things here. And so I'm gonna do it again when you come back, because there's something small, but I'll have to check during my own leisure why this is the case. So I'm going to repeat this question, because now it has taken us some good amount of time. Because this one, you can write it as, okay, that's fine, because, yeah, I'm wondering, it's something is missing. And you see, I will just think about the fact that these can be, why that term alone? Because this is just mysterious. Did you miss something here? There's a square here. And then you get that. So if you divide u squared by this, the quotient is -1. The remainder is 1 out of 1 minus u squared. I mean, all this is fine. Again, then the minus u, this minus u/27 is okay, but only this term. Just 1 minute. Let me just check here. Okay, I think that is best. I'm going to return and do it again, just to make sure, because now I've just cancelled and wrote and cancelled and wrote. Okay, so, okay, yeah, that's what we're going to do. We're going to take a break, and then we shall return again. We shall return again. We can return again at 2:06 p.m. 2:06 p.m. You see, that becomes that integral there. That becomes that integral there. Okay, you see now, that's very interesting that this is the integral, but this also can be written as the integral of this can be written as 1 minus u, and then you factor out a negative. And then factoring out a negative is going to make a difference. Okay, just 1 second, please, because I think that is a sort of very subtle difference that is making the answer to be like very, very different. Okay, I just wanted to, then we're going to take a break. Okay, because it's just a small thing, but I'm wondering why it's making such a huge difference. Why is making such a big difference? Okay. Okay, now you have -1 out of 54. The integral of, okay, Let us expand this thing of pull out the half. Let us pull out the 1/2 from within, okay? Pull out the 1/2. And then you pull out the 1/2, it becomes 1/2, which is 54. The integral of, then this one, you can write it as, it's 1 over that, but you can write it as minus 1 over u minus 1. And then this one, you can write it like that, du. Meaning minus u out of 27. Okay, then now you can get the integrals of this. The integral of this is minus the ln of u minus 1 plus the ln of u plus 1. Okay, you can add C minus u. I'm trying to see because this is a strange little problem. So now, if you have this, then you can write this as u plus 1 over u minus 1, which is what I'm sure the guy did. So now it's just going to change a little bit the pattern here. But you see, the argument is these things must be equivalent to each other. But I can see with the calculator, you know, there's a small difference in an extra term. But okay, okay, because the interest is just making sure that we're able to tell why that small difference, and we're able to get actually the answer that is obtained, because now it's minus u out of 27. Okay, let me see. Plus 1 out of 54. U plus 1 divided by u minus 1 plus c. Okay, this one, u, we know u is sine theta. Check. We know that u is sine theta. Well, it's a very subtle thing. So this is exactly sine theta. I'm trying to see why. And then 1 out of 54. Okay, the u is sine theta. Plus 1 divided by sine theta. Minus 1. Okay. Now here is a triangle. Can you use? The sine theta here is by SOHCAHTOA is opposite of hypotenuse, which is 1 over 27. The opposite is 3x. The hypotenuse is the square root of 4 plus 9x squared. Okay, even if I'm going to do it again properly, I'm interested in seeing why that. Okay, the sine is opposite over that, which is opposite over the hypotenuse, and then plus 1 divided by opposite of hypotenuse. Minus 1. Okay. Meaning that you have minus 1 over 27 minus 1 over 9x divided by the square root. Three x plus the square root of 4 plus 9x squared. Okay, and then you have 4 plus 9x squared. Okay, you can just rationalize this because it's a hierarchy, so you can just write it this way. Okay, we might just get the required answer from this. Let's check. Because the small subtle difference that makes a huge thing, but very interesting that it is the case. I'm curious to check why that. Obviously, then when I return, I'm going to do these again, just to make sure that it's very clear and understandable. Yeah. Okay, we're right back. So we're looking at minus 1 over 9 in that. Okay, minus 1 over 9, and then it is x over the square root of 4 plus that. And then it is 1 over 54. Three x plus 3x plus 0 to 1. Put 1 in the place of x is going to be 1 over in the place of x. You put 1, and then it's going to be 4 plus 9, which is square root of 13. Okay, this one we are getting. It's fine. But now we come to this one. So if you put in the 1, it's 1 out of 54. The ln of 3 plus. You put 1 here, it becomes 3. And this one is 4 plus 9, square root of 13. 3 plus. There's a sign error here. This is minus. This is minus the square root. So it's actually minus the square root. Okay, so it's going to be exactly the square root of 13. Square root of 13. If you put 0, 0. Let's check. If you put x equal to 0, so this one is going to be 0. And this one is going to be exactly 2. And this one is going to be minus 2. So it appears, therefore, that you're gonna, if you put 0, it becomes minus 1 out of 54, the ln of minus 2. Okay. The ln of, this is 2 over square root of 4 is 2, divided by minus 2, so it's a minus 1. Okay, it's a very interesting one, but that is what we're getting. Okay? So, which is, I mean, this alone, the ln of minus 1 does not make any algebra. It's complex. The ln of that is complex, but you can combine it with this, which is the ln. So this one, you pull out the 1 over 54, which will be 3 plus the square root. 3 minus the square root. If you divide by the minus 1, okay, divide by the minus 1 is like multiplying by minus 1, just 1. Negative. Now this is minus 1 out of 9, 1 over the square root of 13. Which is 3 plus the square root of 13. You multiply by negative. That are minus 3. Okay, now we remove this. Just want to see why the small discrepancy could just be actually what we need to get the exactly same answer. And then we shall return from it and just make sure we do it properly. You see, the idea is clear, but everything must be done like this. But it might just be that small discrepancy. And I'm interested in seeing why that is the case. Because I've done it using many ways, and I can see that term must be there. It's not that it's a mistake in the thing. I even used a computer to do it. So you have minus 1 over 9, 1 over the square root of 13. Okay, this term is there in the answer. But now we need to deal with this one. Okay, with 1 out of 54, the ln. 3 plus the square root of 13, square root of 13 minus 3. 3 plus the square root of 13, square root of 13 minus 3. 3 plus the square root of 13, square root of 13 minus 3. Okay, let's check. This is what we have. Okay, now we just need to deal with this one. We need to rationalize it. So to rationalize it, we have minus 1 over 9, 1 over the square root of 13, 1 over 54. Oops. We've gone beyond time. But never mind, I'm trying to verify this, then we're going to do it again when we return. Okay, here to rationalize this, you need to write this as negative the square root of 3, or you can write it as, doesn't matter. You want to rationalize the denominator, so you can write it as minus 3 plus the square root of 13. So you change the sign of the square root by the laws of the conjugate. Minus 1 over that, 1 over the square root of 13. Trying to establish why this. The lid of this. So now you come here, the denominator is going to be exactly negative times negative 3 times negative 3 is a 9, minus 13. The top is minus 9, minus 3 times the square root of 13, minus 3 times the square root of 13, minus 13. Minus 1 over the square root of 13, 1 over the square root of 13, plus 1 out of 54. Okay. You see, this is all fine, but again, my mind tells me we saw something earlier when we did something, so we can use that property because we need to just write this as a perfect square within the absolute sign. Okay, yeah, we're finishing, please, and then we're going to do it again when we come back. But I'm interested, I'm doing research now. Okay, I'm just trying to find out this small little thing here that is. So now this one is the 3 plus square root of 13. This one is the same as 3 plus square root of 13. But it has an extra minus. Okay, the denominator, then you have exactly a 9 minus 13. Plus 1 for that, the length. Okay, you have the minus there. 9 minus 13 is what? It's a minus 4. So it's going to be a perfect square, but there's another minus. And then you have 3 plus the square root of 13. You square this. Minus 1 over 9, 1 over the square root of 13, plus 1 over that. The length of this. Negative divided by negative divides negative, giving us 3 plus the square root of 13, and then you can put a 2 here, and then you square this. Yeah? It looks like we have just got the answer. Minus 1 over 9, 1 over the square root of 13. Okay, so we have that. Looks like we've just done it. Okay, meaning that whenever we have the integral, okay, just remove this one. Looks like just by factoring out the negatives, then it made all the difference. Okay, so now we're going to have the integral from 0 to 1 of x squared divided by 4 plus the 9x squared, and then you write a 3 over 2 dx. We just got minus 1 over 9, 1 over the square root of 13. Plus 1 over 54, the ln. Three plus the square root of 13 out of 2, you square it. 1 out of the square root of 13. 2 out of 54. The ln of 3 plus the square root of 13 out of 2. Check the answer. It appears we've just got the answer. But it's interesting that it was just a subtle sign thing that was done, and then we got, because now this power 2 comes here, and then we have 2 out of 54 is 1 out of 27. The ln. The ln of exactly this one, and that's the answer. Wow. I mean, what difference did we do here to get the answer like this? Because it is the same thing pretty much, except that we just figured out a negative. What a huge difference. I think that the mistake was, yeah, anyhow, but you noted that. So indeed, the answer is this one, but you can see that in the material, it has also been written like this. So yeah, this is the correct answer because I did this using a calculator. So it is exactly this, but this answer can be written as follows, and just write it. Can write it in blue color. So it is 2 out of 54, and 2 out of 54 is 1 out of 27. 1 divided by 27. The ln. Okay, this one you can write it as a square root of 13 out of 2 plus 3 out of 2 minus 1 over 9, 1 over the square root of 13. See, that is the answer. It's exactly the same as the one in the chart. Yeah, and I've checked it using my computer program and softwares. It is the correct answer. So now, yeah, but we're going to return. When we return, we're going to do this question, but we're also going to do E as well. Okay, because we've taken time. I think we need to take a break. We're going to be back at 2. If you are free at 2, if you're not free at 2, from 2 to 4, we can do 6 to 8. So you let me know, either 2 p.m. to 4 p.m. Okay, then we'll just do this again so that you have the correct answer as well. So yeah, I must thank you for joining us. So I'll see you again. Yeah, you let me know, please, on the chat. 6 to 8, 2 to 4. Giving you those times. So you let me know so that we will do this problem again. Okay, this is the answer. It is the answer in the tutorial, but we need to do it again. Right, Aman, thank you for joining us. It was an interesting discussion, but yeah, this problem took us some good amount of time. I think it was just a sign issue there, but yeah, we're gonna do it again to make sure it's clear. Right, Aman, thank you for joining us. Until either 2 to 4 or 6 to 8, let me know. Thanks for now and goodbye. Bye.